Okay, this is Professor Thompson, and this will be the last set of examples on the chain rule. And now what I'm going to do is explain about what happens when you have the chain rule and the quotient rule. And the first way you'll see is when you have the chain rule, but then when you do the derivative of the inside, you have to use the quotient rule. And I'll do example 22 here from 2.5, and it's f of s is the square root of s squared plus 1 over s squared plus 4, and it's all square rooted. So first I'll get rid of that square root notation, and so this is the half power of s squared plus 1 over s squared plus 4. I'm trying to figure out what's the inside, what's the outside, so that's why I use that. I don't say to the 1/2. I say it's the half power of, and then the last thing after of, that's the inside function. So the outside function is x to the 1/2, because s squared plus 1 over s squared plus 4 is inside the square root. It's inside s to the 1/2. So to do the derivative, I would use the power rule, except that I leave what's inside where it's at, and then I lower the power by 1, and then I need to multiply by the derivative of what's inside. So if what's inside, if I call that g, then I need to multiply by g prime of x, or g prime of s. So I need to figure that out, and I'll write that on the next slide here. Okay, so now forget about the big problem. Just look at this one. If I have g of s is equal to s squared plus 1 over s squared plus 4, I want to take that derivative, and I don't need it the chain rule. This is just a quotient rule problem. So it's low d high. The derivative of the high is 2s minus high d low. The derivative of the bottom is also 2s all over low squared. And away we go. So you could simplify that, and some stuff on the numerator would cancel, and that'd be helpful if you were taking another derivative, but as it is, I'll just leave it. So that now needs to be multiplied by what we had originally in the first slide. So the overall derivative here, f prime of s, is what we had originally, 1/2, and then g of s to the minus 1/2, times what I've got written above, times s squared plus 4 times 2s minus s squared plus 1 times 2s all over s squared plus 4 squared. So that is your giant answer for f prime of s. So that situation, the quotient rule, happened while I was working on the chain rule. Another thing that can happen is that while I'm doing the quotient rule, the chain rule comes up. And so an example of that would be 26. So this is 2.5, 26. And this is big G of y. So y is the independent variable. Don't let that confuse you. And this is y minus 1 to the 4th over y squared plus 2y to the 5th. So I have to use the quotient rule because it's a quotient. And this is my high and my low. So I want to figure out my d high and my d low. Well, if my high is y minus 1 to the 4th, y minus 1 is inside the function y to the 4th. So to take that derivative, I would use the power rule, leave y minus 1 inside, and then I multiply by the derivative of y minus 1, which is 1, because y becomes 1, because now it's the independent variable, and then 1 goes to 0. So I also need the derivative of the low, and it's the same deal. I need to use the chain rule, and it's y squared plus 2y is the function inside y to the 5th. So I use the power rule, and then I multiply by the derivative of what's inside, which is 2y plus 2. So now I've got my 4 pieces to do my quotient rule, and I'll do that on the next slide. Okay, so to take g prime of y, it's going to be low d high And so the low is y squared plus 2y to the fifth. And then the derivative of the high is 4 times y minus 1 cubed. And that's going to be minus high d low, which I'll have to write underneath here. So the high is y minus 1 to the fourth. And then the derivative of the low was 5 times y squared plus 2y to the fourth, and then times 2y plus 2. And all of that is over low squared. So it was y squared plus 2y to the fifth, and then that's squared. And so that is your final answer. That probably simplifies, but that answer is fine how it is.